of the benefits though of this is we're gonna use this time to like go back over everything we've already touched over, just to refresh. And also another benefit is that out of the three new concepts that we learned today, only one is like totally new. The other two are like extensions of things that we've already talked about. But they are considered advanced concepts of SQL. So tonight we're going to get into CTEs, window functions, and views. That's our goal for tonight. And was everybody able to connect to the VM? My mouse did. I swear my mouse, I think it's going dead. Okay, here we go. So let me pull my screen up. Okay, here we go. So let's get into this server. Once again, just to refresh, reiterate, everything. So this is a server. This is CPU for the 90s babies. That's the brain that keeps everything in order. So this is a server. Here we have all of our different, yeah, I am, Sade. There we have all of our different databases. These are all of the databases. All of your data is stored within each of those databases. All the relational data, rather, is stored within each of those databases. So first of all, let's get into this healthcare system database. Let's go into our healthcare system database and let's look at our tables here. First things first, and this is not only within SQL, but this is all the way around. I don't care if you are in Power BI. I don't care if you are in Excel, Python, wherever you are. Data investigation is everything. And I was having a conversation today, it was with Amanda, and we were talking about like the different tools that you use within analytics. And I essentially said that like once you master one, the understanding of the others will be more, it's like a shortcut kind of, because it's like you understand data in its foundational sense already. So once you get into Power BI, if that's where you want to go, once you get into Power BI or Excel or Python or any of those things, that core foundational understanding is going to leverage you over in those spaces as well. And one of them was the data relationships, data investigation, data relationships. So let's go and let's look at our table. So we doing our data investigation. We see that this is our appointments table. And these are the columns for the appointments table. We have the appointment ID, patient ID, doctor ID. We have all of this data in this table, all of these columns in this table. But not only do we have these columns, we see that these columns are clearly defined. Somebody, when they created this table, they defined it because it has to have those rules on how you need to structure and store that data. So here we get into this PK, which is their primary key. That's their unique identifier. That's a high level question that a lot of people ask in the technical assessments. What's the primary key? What's the foreign key? That primary key is the unique identifier for that table. Nothing else is alike over there. That foreign key, if something is not foreign, it is not from there. So that foreign key is that primary key to another table. That's that data relationship. Um, Scroll down here and we see all of our data, all of our data within this table. I see, okay, I got my doctor ID, I got this column, I got this column. But with that, you're able to establish those relationships. So when you get to the point on when you start interviewing, and if you have a technical assessment and you got to write some code live, talk through what you're looking at. Okay, first of all, I'm doing my data investigation. Okay, I see my doctor's table is related to my appointments table on the doctor ID. Just talk through all that because it helps the interviewer understand. It helps you convey that I understand data on like a deeper level. Like it's past, I can retrieve this data, but do you understand it? So when you talk through that, be sure to talk through that data investigation and call it that. I'm doing my data investigation. And with that, I'm able to establish these relationships. I see this table is related to this table on this field. So talk through that. Then another step to leverage your data investigation is just to right click and select your top 1,000 rows. And that gives you the opportunity to actually see the values in there. Um, The top 1,000 is a limit. I can say top 10 if I want to. It don't matter. So the top 1,000 is a limit. And when you get into your use cases and you have to join tables, you got to do all that. Always use what you already have. Don't try to like create your query from scratch. We selected our top 1,000 rows. Okay, let's build on it. Let's build, let's test. Let's build our code. We tested it, it works. Okay, now let's add this layer. Okay, we tested it, it works. Okay, let's add this layer. Step by step, literally step by step. So that way, when you apply a change, you go and test that change. You just keep going back and forth, back and forth, back and forth to make sure you get what you need. Um, Another thing with the best practice, these columns gonna stay in the front always. And that's because if I want to eliminate, I could just comment out their code and it's all good. Ain't nothing gonna change, ain't nothing gonna break, and I don't have to go through and keep trying to find everything I'm doing. Um, so that's that reiteration of like those data relationships and stuff. And when you select your top 1,000 rows, it's going to automatically connect you to this database. This is your database. This is your schema, DBO. And what a schema is essentially is how your data is organized within your database. So let's say I have a project that I'm working on, let's say a cloud migration project or something, and it uses 2 or 3 different tables. And I can change my schema to label these tables are for this project. So I can change my schema for anything. You just keep your data grouped by them, by whatever organization you want it to be. And it's your table. Any questions on that? Okay. Now, I think a big part of uh, another thing that is a big point of contention for people is a join. So we're gonna talk about that, and also with your use cases tonight, y'all are gonna still do more joins because like y'all need to do more of them because it's gonna be a big part in what you do, and it's always a learning gap with those joins. For myself, it took me years to like learn them, but yeah. So let's get into these joins. So this is another high level conversation. In your technical assessment, you might have to write code sometimes, but sometimes it might be somebody on the other end just talking through. So they ask you, okay, what are the different types of joins? And with the expectation of you to be able to say, the different types of joins, there's 4 different types of joins, and to be able to explain how they interact, like what they do and what they impact. So with that being said, y'all know it's 4 different types of joins: left, right, inner, and outer. And with that left join, it does exactly what it says that it's going to do. It's going to take all the data from the left table, matching data from the right. All the data from the left, matching from the right. Inner join, common data from both tables. If it's not common, it's not coming. You're not gonna have your data in the output. Keep your inner join keeps that common data. I need a match. I'm looking for a match between both of these tables. Give me that in my output. That right join, same as that left join. I'm gonna pull all this data from my right table and only matching data from my left table. You're not gonna use the right join, but you need to know it. Full outer join, all your data from both or all, because sometimes you can do joins with multiple tables. All the data, whether it is a match or not. Give me all this data. Um, Also, when and if, ain't no if, when you start interviewing and you start doing technical assessments, have a cheat sheet up, and I think the new cheat sheet that I gave y'all, it has like this actual visualization on there. have it in front of you just so you can be able to talk through what that concept is. Because remember, the expectation is not perfection or memorization. The expectation is application. Can you apply what you're talking about, and do you understand what you're talking about? That's the gap. Can you apply it, and do you understand it? So it's okay to use a reference. Of course not. You ain't gotta memorize, but you ain't gonna have to, because just a reference to be able to use as a point of reference for like reinforcement. So that's a very common question as well. Now that syntax of those inner joins, um, select. Y'all know we're gonna select all day, every day. Select, you are selecting from a table. Select E dot name. I'm pulling the name column from my employees table. That's the E. E dot name, department name. D dot department name. I'm pulling the department name column from my departments table. This E is an alias. You go to the DMV, you get your driver's license, first name, last name, alias. Same concept. This the first name, this the last name, but we're gonna call it this. That way, when you're writing your code, I'm able to explicitly say what column I'm pulling this, what table, I'm sorry, I'm pulling this column from. This alias provides you the opportunity to do that because that's what I'm calling it. I'm putting the alias there. Inner join. So I specified inner join this table on these fields. E dot department ID, the department ID from my employees table equals D dot department ID, the department ID from my department's table. That's where those data relationships and stuff is going to literally help you. Like, you gotta know them data relationships because that's how you join your tables. But how I told you, how that understanding of those data relationships is going to leverage you in analytics all the way around, because Power BI does the exact same thing. Like, it's literally to the T. It's called a merge over there. You merge two data sets on whatever the common field is between the both of them. Excel got the same type of concept. Python, the same type of concept. I'm looking at this data. What's the relationships? So those data relationships are going to help you with your syntax as well over here. And remember that inner join only brings back common data. That only brings back common data. Left join. I want all my data from my left table and only matching data from my right table. Your left join and your inner join gonna be, that's the gist of what you're gonna be doing. And why? Because naturally, when we learn how to write, like in school, whatever, we write left to right. So naturally with you prioritizing a table, or you needing all the data from a particular table, you're gonna naturally just write the table first. So they left join. Syntax stays the same. Nothing changes. Syntax changes the same, stay the same, but I'm gonna say left join on this table. And when I say left join, which of these is my left table? Employees table. Yes. Yep. It's that employees table. That left and right. I don't know. It used to throw me for a loop, but I get it. Now I get it just how I explain it to y'all. But it took me a while. But it's the employees table. It's the table to the left of my join statement. I want all of that data. If it's not a match over there, bring me the column, but just populate it as null. I ain't got no data to put in there. So yep. Right join. Total opposite from the left join. I want all this data from the right table, matching data from the left table. I specify my right join here. Same concept. Select E dot name column from this employees table. D dot department name from my departments table. And I'm joining them on what's the data relationship? What is your common field? How are y'all related? Same concept. And with that right join, it's going to do the opposite. All my data from my right table, matching data from my left. Full outer join. All the data from both or more tables, whatever you got in your syntax, because you can join multiple tables. All the data, regardless on if I have a match or not. Give me all the data. Same concept. Filters. Select column from this table. Where? Your where is going to go right underneath this. Where department ID is 1. Where department name equals HR. You literally are stacking your code right on top of each other, piece by piece. I got my code. I got my syntax. It works. Now let me go and start building my code. Let me test some more data. Let me do my filters. Let me do this. Let me do that. Right underneath here. Just like a regular syntax with one table. Select this column from this table where. Put your where right here. Any questions about those joins?
I need to look back at, to be fair, to be transparent, I didn't really look at the recording because I've been like busy at work, but like I need to definitely like refresh myself when it comes to our joints discussion.
Okay, that's cool. And if you have like, if you go back and look and it's still a gap, just put some time and we'll walk through it some more.
Okay.
Yep, that's cool. What else? Oh, aggregate functions. Aggregate functions. That's when we got into the analysis part of data. Okay, I can retrieve my data, but sum, select, sum, column name. We put our column name in parentheses. All of our functions are structured the same way. Tonight, we're going to do window functions, and they structured very similar. Window functions are like aggregate functions, but like beefed all the way up. So with those functions, we are selecting sum, column name from table. This is our ag function. This is our aggregate function. This is what we're applying our aggregate function to, this column. Same thing with average, count, max, min. I can always filter out my data just like this. Select sum, purchase amount from this table. Where purchase amount is greater than 200. Where customer ID is 2. Where, whatever it is. I'm putting them filters right underneath it. Same concept. Same concept. Group by. Calculate this column, but group it by this column. What's the average purchase amount? What's the average status? What's the maximum amount of this order type? Calculate, but group. Select, column name, aggregate function, as, whatever, there go to alias again. Call it this. From this table. Group it by customer. Group it by this column. Count this, but group it by this. Count or calculate, but group. Calculate, but group. Literally, they group by and they having. That was another thing that was real weird to me. Real weird to me. But the way that I understand it now, it's like, oh, you mean like group for real? You literally want me to like put this in a group? Oh, okay. And that group by allows you to calculate by group instead of that full table. Because remember, with this one, it's just gonna pull the calculation from that full table. But that group is gonna calculate it, but group it. So yeah. Having. So you got group by, and then you got having. Having is a filter too. It's a filter, just like where, except having is a filter that you use for aggregate functions. Having the sum of greater than 500. Having the count greater than 10. Having, I'm applying a filter, but I'm applying a filter to an aggregate function. Whereas where, I'm applying a filter to the full table or the full column. And having always comes after group by. Because when you think about it like logically, the way your syntax is, select these columns, we're pulling this data from this table, group it, and then I want you to filter that group by whatever my calculation is. So it's gonna logically kind of trickle down in a way. I'm gonna group it, now I'm gonna filter that group. Any questions on that?
And you have to group it by the aggregate function.
You gotta group it by a column. You apply the aggregate function, but you group it by column. You use having for aggregate function.
I'm sorry, like the filtration, yeah.
Yep. That's what used to throw me off. Like you use having as like, okay, if I say having, okay, another weird quirk that I have. The way that I remember that is when I say having, for some reason, it's like, okay, have your stuff together. Have a total amount, have a sum, when I say having, the way that my brain understood that fully is, okay, you got to have your stuff together. Because when I'm applying that filter, I'm applying that filter to something that's already together. Having a sum, having a count, having a like, oh, it's already calculated. So okay. That's how my brain like conceptualizes it. Whereas where is like, oh, okay, where this column equals this. Having is having some greater than this, having many greater, whatever. But yeah. Any questions on that? Okay. Case statements. This was a big one too. And tonight, like I said, when you're doing your use cases, I'm gonna give you the opportunity to apply these again as well. So case statements fall into essentially conditions in a way. And how I was telling y'all where like once you like understand the foundation of things and like truly understand them, it's gonna leverage your understanding in data all the way around. Because all analytics tools use something similar to this. Python has loops, if this, then, if this, then. And it's literally just like that, except it's written, the syntax is slightly different. But the concept remains the same. If this condition is met, then that. Same thing. Excel has one, if, it's called if in Excel, it's like if this cell equals this, then that. Same concept. SQL has the same thing, but in SQL, it's a case statement. So it's like, okay, it checks the condition, and if this condition is met, then this is the value that I want published out in my output. So here we have select, column, column. Now we're going to get into our case right here, because also remember that we're going to treat our case like a column, because that's what it's going to show up as in the output as a column. So select column, column, case. Case when this column, whatever your condition is, then this. When this column, whatever your condition is, this is greater than or equal to 80, then B. When, like you just keep going, when, column, condition, then call it this value. Anything else, call it this. End. So I'm ending my case statement as whatever column I want to name my column as. Grade. This is my column name. That's an alias. Once again, from this table. Filters right underneath it. Where um, student name is this, where score is it, whatever your filters are, whatever your conditions are, put them right in there. Same concept. That is essentially what we learned in session 1 about them conditions. This is like an extension of that understanding from those conditions. I'm applying a condition and I'm creating a value based on it. Any questions about that? Okay. All right. So let's get into what's new. So what's new tonight? CTEs is our first, like this is our first objective for tonight. CTEs. CTEs are also called common table expression. Now, essentially, a CTE is like a temporary result set. And the way that like my brain always looks, the way that I learn is I always like try to take something back to like what I already know or like something that I use. And a CTE, the way that my brain conceptualizes it is literally like a paper clip. Like I have my the first these paper clips, I'm telling my age. I don't know. But anyway, I have my logic and I'm putting a paper clip in it and I'm gonna come back and pull from that logic when I need it. So let's say you have a in your code, I want to be able to pull a subset of data from this set of data. Oh, you know what? That's another thing we need to talk about. Let me pull up subqueries real quick. Here we go, right here. Let's talk about subqueries too, because we did that last week in the previous session. I want to make sure we talk about that too. So a subquery is essentially a query inside of a query. A nested query. Subqueries and nested queries, they're the same thing, literally. People just call them differently. And a subquery is literally a query inside of another query. I'm going to use this syntax as my condition for this syntax. I need this output and I want this output as a condition for this output. So here we have this syntax, select the average from employees. We have the average salary from my employees table. And here I'm pulling the employee ID, employee name, salary from my employees table where salary is greater than the average salary. So that subquery allows you to use this output as a condition for your syntax, for your code. I need that, but I need it to compare it to something else. That's that subquery. Give me that and hold that and use that as a condition. Use that as a baseline for something else. Another way to do it, or another like realistic use case is, let's say I need a population of data, a population of people. And in that population of people, I write my query, write my subquery to capture that population. But then I want to use that population or that subset of data to compare it to something else. So that's a good baseline for like what a subquery is and how it's used. Any questions on those? Okay.
Do you suggest like starting your subqueries from the inside out?
Um, I personally do mine like, cause the way that I write my code is like if I have like if I'm like literally I use this tool today. And if I'm utilizing like I start from the big pool and then hone down. And the reason that I do is because, like, okay, let's say I'm looking for a subset of data from a certain state or something. I go to my main table, select my top 1,000 rows, and then I'll just start like building on what I need based on it. But I could see how someone could do it the other way too, though. It's like, okay, well, let me start with like the first pool first, and then use that query and like build it into a subquery into my main query. I could see both ways. Yep, I could. That's a good question, though. Um, what was that? Oh, right here, CTEs. Did you have any other questions? Okay.